So what I'm going to show you about is sharing resources with grid and cloud. We believe in adaptive computing. There is an evolution to HPC, and it's really our mission to help see that evolution, to really help see it through. There are perhaps a couple of slides here I'm going to skip. This one's very notable. We've been a really trusted source for HPC leaders. We were on the first petaflop system, first 2 petaflop system, first 10 petaflop system. And again, we're the #1 most broadly used vendor, according to an IDC study in 2013. So we are on one of the first grid systems, and we currently run the world's largest private cloud implementation. So our software, Moab, that decision engine, runs the largest private cloud in the world. 10 different data centers, and we have displaced about 10,000 nodes from this company. I can't tell you who they are, but I can tell you they're a bank in America. You guys got it. Industry recognized, more bragging, IDC recognizes us as a system management innovator. We were a Gartner Cool Vendor for Cloud this last year, a Red Herring Top 100 Innovative Companies in America. And we're on the top, again, as of not this last iteration, the last top 500, we were #1 in the world on Titan from Oak Ridge, and on the Green 500 on Beacon at NICS. So. Great. So why cloud or grid? A lot of you are wondering, I have this siloed HPC system, it's good enough, right? So why cloud or grid? You may run into instances where you need to collaborate more. You need more of an end-to-end process. You need to bring departments together, or even outside organizations together, right? You might need additional resources. You may have specialized resources that you need a wide range of users to have access to, right? And you may want to get buy-in from multiple companies to reduce upfront budget costs. That last one, actually very important. For any of you that may be director level, may be looking at implementing a new HPC system, if you have needs that are great from time to time, getting additional budget from outside, fundraising, perhaps even for time on the system, is a great way to get what you need from a hardware perspective. Great. I'm going to spend a little bit of time on this slide. This is what we call our clustered grid and cloud maturity. At the bottom, at #1, we have cluster workload management. That's a pretty siloed system. It's a great HPC system. Now, in pitching this to you guys, I want you guys to keep in mind, moving up the maturity level is not for everybody. It is perfectly acceptable to have one cluster that's siloed, or multiple clusters that are siloed. It doesn't necessarily mean, hey, I have to move through this model. Sometimes it makes sense for you to move up. You may need more things. You may be doing more outreach to the community or to private organizations. And I'm going to show you a few use cases, and I think they're very compelling use cases of companies we work with that have kind of moved through that evolution of, beyond HPC to maybe grid, and then maybe to cloud and or shared resources. And we feel like bringing HPC and cloud resources together is going to be very beneficial for a lot of organizations. But again, not for everybody. The second level, really what you're seeing is, in this location front right here, you're seeing kind of a local area grid. You may have multiple systems. How many of you guys run multiple systems, by the way? Multiple HPC systems. There's a handful of you, right? It's not uncommon. It's actually very common, especially when you're going to replace hardware. You're going to upgrade. In a lot of cases, it doesn't make sense to pull nodes and swap them. That's what Titan did. Jaguar became Titan, but it was a great use case to be able to do that. That's not going to be the case for everybody. Maybe you need more GPUs. Maybe you need specialized hardware. So, on the ease of use side, at this point, you're looking at an application submission model. You need a portal. You need an easy way for your users to be able to submit things, right? And then, of course, on enablement, this is really the point where accounting kind of becomes important. The reason I say that is your user base is going to grow. Your user base may be outside of just your one cluster. And so it's very, very important to consider accounting at that point. And I'm going to show you a couple use cases of why accounting becomes even more important in the future. So keep in mind, this accounting piece is really important for these next levels. Very important. On the third level, what we're looking at is a wide area grid. You may have multi-sites that are not in proximity to one another. You know, you've got longer distance to travel. And there's ways to do it so those still can be shared resources in a grid environment. You're going to see things like remote visualization. Rather than well, I hate to say wasting, but spending a bunch of money to have each guy have his own individual workstation that has a lot of power, you've got all your power on the server ends, and they can view it remotely. We have a demo of that actually right on the other side of that tower right there. It's a great tool for any of you that use really, especially graphically intensive applications. At this point, you're going to start to do some automated provisioning. Automated provisioning can become very important in this environment. Most of you, I would guess, use Linux. I'm not going to ask a show of hands. How many of you are running any sort of Windows? VDI, maybe Windows HPC server? Anybody? Not many. A couple. It becomes very important to be able to provision those things. How many of you run multiple different flavors of Linux? You just run one. Wow. You're strong-arming them. All right. A lot of people run multiple instances of Linux. They run, you know, CentOS 5, CentOS 6. They're running Scientific. We, at our company at one time, were running Gentoo, Debian, Ubuntu, a bunch of different flavors, right? So it becomes very important to have that automated provisioning. So your admins are not spending a ton of time setting up systems for everybody, right? And then we get to our cloud maturity. This cloud example I'm going to show you is actually from HP. They still use HPC. They still use HPC pretty extensively. But they do have some cloud services available where they make sense. And I'm going to show you, they have future plans for cloud bursting into the public cloud, but right now they have a private cloud environment using their own software and their own hardware. Of course, you have to have a self-service portal. And really beyond just automated provisioning on the OS level, you really need to be able to provision on an entire software stack level. That's very important. Otherwise, your admins are going to hate this system. And we'll show you how that works, how it's easy to stand up a LAMP stack in that environment and have it work extremely well. So on the level 2, I'm going to show you real quick. University of Utah is a great example for us. They're very close to us. We're based in Provo, Utah. University of Utah does the second level actually very well. And we'll show you that use case. NCSA, and I'm sure many of you are familiar with NCSA. Do we have anybody from NCSA in the crowd? No? They have a program called PSP. And this is an outreach to private organizations. So this is outside of Blue Waters, outside of their large-scale computing environment, but a very powerful tool. We'll show you kind of how they use that. The last one is HP. HP obviously does a lot on the HPC side, but they're also very innovative on the cloud side as well. So we're going to show you some of those use cases. So we're going to show you the shared community cluster first. I'm going to go through this rather quick. This is the University of Utah. This is not an uncommon thing to see. Beyond just a siloed system, they actually have multiple systems that they want to share. They want to share between the systems, but they also share externally. They want to leverage leftover cycles. So when they have their main computing environment and their remote access environment, they want to be able to access it from the inside. Say, hey, we're not using our remote access, we're going to spill over into that system. They do have an accounting system, very important, because you'll see user departments, they have their general university, atmospheric sciences, chemistry, their genomics department, but they also have the Utah State Clean Air Group, which is a state-funded group, not associated with the university. So they're accessing it from the outside. And so they've been able to leverage that remote access system, but also their internal users can spill over into that system if it's not being used. And it's a great setup for them because they can help meet the demands of Utah state government, but also allow for some scaling up for their internal users. So I'm going to show you a hosted HPC service. A gentleman by the name of Merle Giles came and presented this to us when they very first rolled it out. I believe it was about a year ago. And they call it their private sector program. So what they're doing is they reached out to organizations that said, hey, we want to set up this system so you can access it during peak times. Or if you don't have your own HPC system, you can use ours. And so they got partners from Boeing, Dow, John Deere, Caterpillar. I mean, there's a who's who of Fortune 500 companies there, manufacturing companies primarily, given that they're in Illinois. So, but what they're able to do is they're able to make this system available remotely. And again, this is where that accounting piece, that user portal, becomes very, very important. Lastly, I'm going to show you HP system. Okay, so they have their technical computing, their HPC cluster. They also have VDI, and they're running applications remotely for a lot of their users internally and externally. Right, so they're not only giving access to HPC services, but also cloud services as well. And the important thing here, again, like I said with the provisioning, is they're not just provisioning OSs. They're also provisioning entire software stacks, which is extremely important. The great thing about that is it's a self-service portal. So your admin can decide, this is what makes up an optimal LAMP stack, or here's 3 different use cases of LAMP stacks I want to create for those to be provisioned. They can go to the self-service catalog, select one of those, and provision it themselves. So it's very important. And it makes for a very efficient, very collaborative, and shared computing environment. This is a real quick diagram of how it works. HP uses a private cloud product called Cloud Service Automation, CSA. CSA has its own user portal. They also have a workflow product called Operations Orchestration. Any of you guys ever heard of OO? HP OO? Yeah, a couple. Right, so they set up their OO flows, and Moab takes over. Moab is really the decision engine, not only on the HPC side, but also on the cloud side. And that's where our piece fits into HP system. And obviously they send it off to Zen server, vCenter, they're sending it out to their Blade servers. Right? In the future, they have plans to be able to burst to public cloud. And this is something we're working with them on. Bursting to primarily probably EC2. HP has its own public cloud initiative. But initial steps will probably be web services. Amazon Web Services, which is very, very crucial. If you ever reach capacity, you want to be able to meet your SLAs, your service level agreements with your users, you can do that with overflow capacity to the public cloud. This is just a quick architectural diagram. In this case, CSA and HP software is the interface and the muscle. Moab is the decision maker, it's the brain. It tells it where to go, when to move, those sorts of things. So the things we provide to that solution that make it smart, we provide transparency to the cloud, right? We can improve for future capacity. We can improve diagnostics and reporting. We can also help pack the workload tighter in that virtual environment. Moab's really great at overcommitting and being able to move things off when, if there is an increase in workload or if there are issues. Of course, we can guarantee future service, right? We can guarantee future reservation, which is very important because you want your users to be happy, right? And then also we can do scheduled maintenance, which is a great benefit. Being able to quickly move things off to do maintenance, emergency maintenance, or do automated maintenance as well. This is just a quick, diagram of how we see tying not only your storage solution, big data, technical computing and HPC, and cloud together. And that's really our goal. And we think we're well suited to do that because we have such a rich history in HPC and workload management, but we also have a very robust solution for private cloud. And we have great partnerships with companies like HP for some of those private cloud implementations. So, again, that life cycle, that evolution is not for everybody. And we know that. If it is something you're considering, a program similar to maybe NCSA's PSP program, the private sector program, we think we're well positioned to be able to help you get there. And we feel like Moab as a decision engine is really an industry leader, being able to make appropriate decisions in these environments, but also being able to tie those environments together. So And again, our goal is to help you achieve results faster. That's the entire goal of this. A lot of times it is going externally. Sometimes it is just a like I call a siloed HPC environment, an internal HPC environment. So that is the presentation.